The containers.
Hello everybody, and welcome to today's Aircast by AirPair. My name is AJ. I'm the moderator for our workshops here. Today we have Greg Osuri giving us an amazing talk on containers and how to use them to create modern infrastructure inside of our environments. Docker is pretty cool. We here at AirPair are really interested in Docker and what's going on, as well as just general containers and how to manage them and going from development to deployment. I'm going to go ahead and pass it over to Greg and let him begin his workshop.
Oh, wow, that was cool. Thanks, AJ. This is, I like to think this as a real workshop. That means you work with me. So I'm not going to present too many slides, but I'll probably show you a lot of stuff and a lot of code. And I want this to be interactive. We have, I think, a good decent size of audience that we can actually be interactive and learn a lot of things. So that's the format. So please feel free to stop me if you don't understand anything. Feel free to ask any questions in the middle. Let's keep it fun. Let's keep it interactive. Well, so containers. Containers are interesting things. If you look at how traditionally software has been, managed or written, a few years ago, maybe talking about 3 years ago, if you were to give me an application and ask me to put that in production, first thing I would think is, well, get a cloud server or a VPS server, Amazon or whatever. Maybe get a small instance, maybe get a big instance. I don't really know because I don't have too much choice. I get whatever small instance I think was most popular there and was cheapest if you want to run in a decent unit size application. You may not utilize that thing completely, so you would again break it down to multiple sub applications using Nginx or whatever, to better utilize your resources. And then you have this funky domain name routing. You would have all this, whatnot, right? I mean, we all put applications in productions and we all manage that. Containers came around and kind of said, no, we're not going to do that. No, we will let you reuse your applications the way you want to reuse, but we're going to give you that abstraction of isolation. That's when I think I really started getting serious about containers. Then I started looking more into it. What essentially came down to is it is a runnable, a completely isolated Linux environment given to you. Completely runnable. You can take that thing, put it in any operating system, and run it. With that kind of isolation, it presented interesting deployment architectures. When you can actually package one package, take that anywhere you want to go, and pretty much run it, you can start playing around with interesting architectures like, by changing a few variables, you can have 100 environments you want to. Before it was well, we come here, there's a QA environment, the development environment, staging and whatnot, but you can have the same exact package in your development and ship it to production without changing a thing inside the package. And I mean that to me was wow, the flexibility that didn't exist before was a game changer. And another interesting thing that happened was, if you think about how virtualization the history of virtualization, why we started virtualizing servers to make our boxes, our big boxes, more reusable, right? And traditionally that was achieved by something called a hypervisor. So you would have a Linux kernel, an operating system, and you would have another layer of software on top of the kernel, which will essentially provide you a abstraction that looks exactly like a full-on operating system, and you can put another kernel on top of that. So you have this two double kernels stacking up on each other. And that was kind of cool. I mean, that was like, well, you had this redundant hardware and you really don't know what to do with it, so why not just add another layer of abstraction and give another API and that give you flexibility to deploy whatever application you want to. But the problem with our approach was the double kernel kind of didn't go really well because you're literally trying to mimic what a kernel does best, basically, managing application resources. So folks at Linux actually work around this problem. And this virtualization doesn't really work at hyperscale because the amount of performance you're going to lose when you're putting double kernel is significant. So when you do it in a smaller scale, it's all right. But if you do it in a hyperscale like Google or whatnot, you're going to have to squeeze for resources individually in order to optimize it. I mean, there's huge cost savings, right? So people started like really focusing on how can we use a kernel, the operating system itself, to provide the isolation we need to. So that's really, I think, the birth of containers. And I think Google was the pioneer of containers. And there are instances where they would run Google Maps and Google Docs on the same box. I mean, they still do too. Actually, they run both on the same box, and it runs pretty well. And I think the performance gains they've gotten with the containers versus versus hypervisor were like 10x, literally 10 times more performance, more bang for your buck, going with kernel-based virtualization instead of hypervisor-based virtualization. The real value doesn't, I mean, you do see some value in the cloud in terms of deployment architectures and flexibility, but it really comes down to when you have a bare metal box. When you have a box with a kernel installed and you virtualize that, and there's no other, I mean, you can't beat Linux container performance. And that's becoming more relevant if you think about where we are going with deployment. Now we have Intel or x86 based systems providing fundamentally in the data centers. Now we're going to move to more optimal ARM based processors, right? When you think about deploying a Ruby on Rails application on ARM based processor, Linux kernel, Linux containers is what you would essentially use instead of hypervisor. And containers are everywhere. They're in your iPhone, Android. I mean, every, I guess, distributed or mobile platform today uses containers. So it's literally that kind of flexibility that never existed before. And so if you really look at other, buzzwords about containers and what I think in the recent past, what really happened was Docker came along. And containers traditionally existed in one form or the other. If you think about what a container is really, is basically, isolating resources. That means namespacing and CH rooting, basically jailing the entire process, not being able to access other processes, and resource constraints like C groups, for example. You could literally set limits in terms of what kind of processor scheduling you can use, or what kind of memory limits and whatnot. And that what is a container is basically a completely sealed deployable application. And you can take it, run it everywhere. It's super lightweight. It's a full-on Linux environment. So that is basically what it is. My presentation is not much today. I have very, very few slides. Most of my work for this presentation is on GitHub. So if you actually go to github.com/geosuri right now, click on repositories, you should be able to see all the things that we're going to be doing. What we're going to be doing really is, I'm going to show you how I use containers, how I mean, when I said that these containers give this new deployment architectures, what I really mean by that is basically today I can take a application from GitHub to production in under 6 minutes. And I can do it in about 1,000 servers in 6 minutes. I'm going to show you 1,000 servers, although that's certainly possible with the code I just wrote for you. But I created one server. The workshop is basically get. Oh no, sorry. Was this sharing my screen earlier? No, I wasn't. Was I?
You were for a moment, and then you went back.
All right. And the stack that I wrote the workshop is basically has 4 components. First component is called Terraform. Terraform is a tool to launch common infrastructure. So basically, you can define templates that you want at an infrastructure level for launching. Basically, your instances, your DNS servers, your load balancers, to your firewall rules and whatnot. The whole shebang of the whole infrastructure, the launch infrastructure, can be defined in this tool called Terraform. And we use something called Chef to, after we create the infrastructure, to bootstrap these boxes. So what install in them, and the packages and the configurations, the things that we bring together. And we use something called Surf that'll basically take these boxes and manage them. Make them communicative, make them failure-proof, orchestrate them where what goes in scheduling wise and all that. And we use Docker as a container management tool. It's basically a fleet manager. So it gives you a nice abstraction to interact with these containers, and gives you a nice workflow. You have this ability to create a container, commit your changes, something very similar to Git. I would think Docker is what it is. And architecturally, the way I have set this up is basically, as soon as you commit your code to Git, there are two types of boxes in this infrastructure, in this workshop. One is a provisioner box. The primary function of this provisioner box is to take the source code and build you a runtime container. So it'll create all the software, it'll install everything you want to run a container. Also does management of the releases, like archiving, building, and storing and pushing to storages, and giving you the tar file so you can put it in your development environment, whatnot. And the runtime part of it, which is basically another container, another host, which will take what the provisioner built and run it in a OS agnostic environment. What that means is you can take what the container built, which is on Ubuntu, and put it on a Core OS box, a super minimal Linux box, or a Red Hat box, or whatever distribution. You build your own distribution if you want, but you can still run that that runnable unit. It also does other things like actually making sure it auto heals. If disk is up, or if memory is out, or if it needs more space to grow, and put in another box and all that. So the runtime unit, the runtime host is basically responsible for scheduling and managing the runtime of the application. You can have 1 or 2 provisions, but you can have hundreds of these runtimes, depending on whatever scaling requirements you have. So any questions so far? Do you know where? Oh, sorry, my screen is from my laptop. It's hard to see the letters on the slide. I thought I had the worst slide on the planet. Hang on a second. Steen, can you see me? Cool. I really don't have too much slides. What I'm going to show you is a little demo as to what I was talking about first, and then I'm going to show you how I did it, so that you can take home with you and play. So let's see. First of all, I'm going to show you my Amazon screen. I guess that's a good start. Oh, great. As you can see, I have two boxes here. I have a provisioner box and I have a runtime box. A provisioner box, like I said, it just builds applications. A runtime box runs the applications, right?
Greg, make your window a little bit larger and zoom in just a little bit.
Yeah, so,
Still a little bit bad? Okay, let me see. Is that better?
Yeah, that's better. Great.
All right. So let's put this. This is the, on my right is the runtime box, and on my left is the provisioner box. So I'm going to tail the logs to show you what's happening on the background. This runtime box has a deploy log, which basically keeps track of all the deploys that's happening on this box, and this compiler box just compiles stuff. So I'm going to first, I guess, show it. Let's go to the runtime box and see what's running on that box. Basically, I have a little application that's running on a container. I'm going to go change the code here. See, deploy it on to 22. And I'll time this application just to see how fast it compiles, right? Stretching the application source, then it'll compile the application. This is not this is a Ruby on Rails application, so it's really a simple application. But I mean compiling the application, where it comes down to is building a super minimal version of a runtime unit. That means installing Ruby on Ruby and installing Node.js, getting all the gems. While it installs, it actually creates a container called a compiler container. The compiler container, what it does is it installs the compilers, the GCCs, the development versions of the packages, not the runtime versions, but development versions. It'll install the gems. It'll make sure the gems can be installed by making sure it has all the compilation libraries, etc., etc. Once it compiles the application, packages everything, it fires up another container called the runtime container. So the runtime container has a little different set of packages, not the development packages. That means it doesn't have all the man packages. It doesn't have all the dev packages. It only has like libxsl or some very runtime units. So it's very minimal. It's almost like 200 megs smaller than the actual compiler package. It builds a super minimal package, and then it ships it off to a central repo, which is S3, right? And it sends a message using something called surf. Now we use a tool for service discovery. That means in order for these containers to communicate with each other, these host box, they need to be able to discover themselves. They need to guy on the right, which is the runtime guy, needs to discover the build time guy, right? Or the build time guy, vice versa. The way we do that is through evented model. So we actually don't really, I mean, even though these boxes know each other exist, they actually participate in a single cluster, which is self-elected leader. So one guy goes down, the other guy doesn't really, get affected. And they communicate by sending messages, just like how you would do JavaScript or any evented programming language, as a matter of fact. Once a guy is done compiling this runtime unit, he gives a message saying that I am ready, I've built a new container, and whoever is listening to what I just built, you go ahead and deploy the application. So real soon we're going to see, once it's done building this app runtime container image, it'll throw a message. If the demo goes a good to me, it'll work. So there are several things that are happening. First of all, it's there's lots of moving pieces here, right? So it's pulling the git resource, making sure the code is clean, making sure the code is not old. It's making sure the containers, all multiple levels of containers. I'll just show you the code in a bit. Multiple levels of containers, all the way from skeleton containers, the base Ubuntu, container, to your base Ruby containers, to your base application containers with the environment variables and whatnot. Make sure all those exist, and and making sure it can actually reach the central source repo. And it took about 3.5. That's under 4 minutes to build a container through an event called deploy, right? And as soon as through this event, this got picked up right here, which is the runtime unit, and this could be like hundreds of them, right? So to give you an idea as to what containers at what scale they used, Google, for example, deploys about 2 billion in a week or something like that. Roughly 2 billion containers in a week. At that hyperscale, because this is pull and not push, because this guy is literally saying that I'm ready to go, and you just go pull the image, you can build these things at massive hyperscale. Here we just have one example. So, but imagine you can doing this in at hyperscale. So let's see, we have built it. There you go. So we actually saw a unit deployed, right? So code walkthrough. First of all, when I start off this infrastructure project, I would start off with the actual defining what boxes I have, right? For that, I use something called Terraform. In Terraform, you basically, if you go to geoseries/AP workshop, you define your infrastructure, what security groups you have, what instances you have, right? And this is exactly like how you would go and define in Amazon console. But this is code, it's repeatable. I can share this with you. You can literally run this guy and actually create exactly the same thing I've created, right? And the way this works is it basically depends on something called the user data. As soon as this resource fires up, it'll send this bootstrap script for it to run. Same thing here. It sends another bootstrap script for it to run. And in this resource, we notice it says it depends on the provisioner box. That means it'll make sure this provisioner box boots up before the runtime box is ready. So, because it needs a provisioner to compile the packages and give it, right? It also creates a elastic IP address for you to attach with the provisioner instance, and creates you the firewall rules and and whatnot. You're going to run this, and it's really easy to use. It's really simple to create. You can define infrastructures, make them repeatable, and you'll be spinning up things really fast. I'll show you how to spin up an instance after I'm done with the walkthrough of the code. So when I say it actually runs a script, the provision script, what that really comes down to is this. The provision script, this is the thing that gets installed. First, it installs the Chef Solo, right? So there are two versions of Chef. There's Chef Server and the Chef Solo. Solo is more lightweight. It doesn't require, certain interaction. I kept it simple for this demo. So Chef Solo was amazing. I love Chef Solo. Instagram, and I think I think a lot of modern infrastructures today use a combination of Chef Solo and containers. So there's separate discussion about Chef Solo and Chef Server, but for this demo, Chef Solo is amazing and it's really lightweight. Sets its host name, and it actually downloads the cookbooks, right? And puts it in a run loop. Make sure it runs at least 3 times before it actually fails, because sometimes you'll see failures because of slow connection, or I don't know, it could be anything, right? Infrastructure, you never know. So what are these cookbooks, right? These cookbooks are basically defining what this box needs to run. This line right here tells Chef to run this cookbook called a provisioner, or the default recipe in the provisioner. So let's walk through what those cookbooks are. So if you look at provisioner, the first file that gets called is the default. I know there's a lot to take into, so please stop me in case you have any questions right away, or else you're not, well, sorry, I'm just jumping around files, where recipes, well, default. And cookbooks make it extremely simple to manage infrastructure. So here, I am basically installing Docker registry, which is like a private registry that you can use to check in your Docker files. I'm installing something called a build compiler, that I'm making the build compiler. I'm creating another file called build compiler under my bin directory, which basically compiles my application, right? All the magic of compiling a build, bringing everything together, is happening in this. I'll show you that in a second. But this is what a recipe looks like. It's really simple. It's really steps of things that this box needs to have in order to run, right? So 3 things. It has a Docker registry, it has a build compiler, and has a program called compile application, right? Compile application is what I ran earlier here. So this basically did all the compilation. So compile application, if you look at it, it'll call this build compiler program, and you give it a repo it needs to pull the code from, which is my public GitHub. It'll create from the compiler. Compiler actually produces a runtime unit. It'll create it'll boot up the runtime unit. It'll copy the the application directory, which contains all the dependencies, into S3, and it'll throw an event called deploy event to the surf, and of course it cleans it up after that. So this is what happened here. And if you look at this compiler, where all the magic happens, now you could write this compiler in Chef. I wrote it in Bash so that it's easy for people to understand, easier than Chef, or it's more acceptable. Bash, by the way, is one of my favorite languages, or systems of programming instead of a language. It's not really a language if you think about it. Anyway, so here you have here you have two set of packages, right? You have the runtime package and compiler packages. If you notice, in order to compile the application, you need unzip, git, curl, whatnot, right? Build essential. You need all sorts of compilers. You need the development versions of the packages. You need OpenSSL and whatnot. But to run the package, you only need a few things, right? If you actually, this is amazing because you're able to control at a unit level as to what you need to run the application. You're not doing a kitchen sink. Like if you go to Heroku, there are about 300 something applications that are installed they use containers, but holy shit, I mean, your application gets so bloated and so inefficient if you have and so many security risks, right? I mean, I work with so many security people and they're not going to allow me to have a compiler in my production server. This is the main loop run method of this program. All this does is it builds a base image. A base image is a skeleton image. It has the structure of it takes from Ubuntu and it creates a structure of what a container should look like. And it builds what a Ruby application should look like, and it'll build an image for a compiler container to be able to compile the code. And you'll get the code, it'll compile the code and copy the compile code to a separate directory. It'll build a runtime image based on the compiled code, and it'll clean up. So this will give you everything basically if you actually follow each of these methods. So I'm not going to go in detail. It's out there for you to go play around with. But feel free to ask me any questions, leave a comment, just email me or whatever. I'll be more than happy to explain to you. But to keep the discussion short, I'm going to keep moving forward. But essentially, these are the main set of steps, right? So taking building all the cache containers it needs to build, and fundamentally giving you a runtime image for you to work with. That's all the magic there is. So once you're done with once you got your compiled image, you basically put it in S3 and you throw it out there to whoever is listening that, hey, I am ready to get my compiled image. Go put it out there into production. That's essentially what it comes down to. So that's the provisioner side of things. So what happens on the runtime side of things? How does this thing run, right? It's fairly simple, actually.
Hey, Greg, I think Steen had a question about what you just said. Steen, if you want to go ahead and shoot your question.
I'm not looking at... Sure, Steen, go ahead.
Am I coming?
You're breaking up.
Yeah, Steen, if you want to just type it in the chat, then I can...
All right, yeah, all right.
Yes, exactly. So I have a separate container for building the app called the compiler container. I'll show that. And the reason I have that...
I'll just repeat the question real quick. It was, Steen is asking if you have a separate container for building the app and also one for running it.
Exactly. Yes, I do. And the reason for that is because they have separate set of applications, packages that you need. Like you wouldn't need a compiler to be running in your runtime container, but you need a compiler to get all the gems and install all the gems and whatnot, right? The compiler container needs the development versions of the package. If you see like libSSL here, the development versions, all the development libraries, all the whatnot, the whole kitchen sink in order to compile. But the same library in order to run is this libSSL 1.0, right? That's why I have two separate containers, and I like to keep them separate. And I think it's way more efficient way of designing applications. And if you look at what a compiler container looks like, a build Ruby compiler container, it actually, gets the Ruby source code from Ruby build. It'll build the Ruby version that you want, and it'll install the Node.js binaries and everything into application directory, app vendor, right? And once it's done building this, at the end, it'll just, once it's done compiling, you see it'll install all the bundlers and all that. It'll install all the, bundle and whatnot, and then it'll copy the application directory, the app directory within the compile container to a separate directory, and it'll build a runtime image, build after runtime container, based on that directory, the app directory. The app directory has all the compiled binaries, everything it needs to run the application. So good questions. The question is, how does both of those containers connect? They don't connect. They don't. Once I'm done building the once I'm done building the compiler container, I copy the application directory. So the application directory in the compiler container has all the dependencies to my host box, right? The box that's actually hosting the containers. Then I build the runtime container by adding that host box. If you see this runtime container, it doesn't have anything. It has a runtime packages, it sets an environment variable and secret base or whatnot the Rails needs, and just adds the application. It doesn't connect. It doesn't talk to the compiler container. And then and then it creates an image out of the container, and then it just ships the container. So they don't connect at all. Does it answer your question? Oh, that's Yogesh. Okay, cool. This repo is out there for you to go use it. I think I did. I might be running a little short on the documentation, but I promise I'll update it by tomorrow. I wrote a lot of inline documentation, but I haven't really got outside. Let's see. Where was I? So okay. So yeah. So if you look at the runtime, box, the recipe for running this application is really straightforward. This guy, it's really straightforward. It uses something called Surf. Surf is a Gaussic protocol that just talks over network or UDP. It's really lightweight. It's really nice. It's done by HashiCorp folks. Same guys who did Terraform and Vagrant. And what Surf does, Surf has this thing called handlers. So you can throw events and handle them. And you can write you can throw an event called deploy, right? And you can handle that event. Let me show you the event handler, how it looks like on the box itself. So this is by running these things, I use something called Run It, which is a process manager. It's amazing if you haven't used it before. But Run It defines system services, right? So Surf is running with handlers. The runtime for that is on run. You can see here, Surf agent is running with the debug and binding to whatever. But the most important thing is the event handler here. It says on user deploy, once you get this event from the cluster, run the script. So if you run the script, if you the sorry, anybody have a question? Cool. The deploy function, which polls, starts, and runs, basically first it polls the latest source code from Amazon. It'll import. Docker has this import method which can you can point out a URL and import. It'll first create a random container image. It'll import the image. It'll then stop the running containers if there's anything running, and it'll run the environment variables, basically passing to the. This is how you run a Docker. So here you're essentially saying map port 80 to 9090, put in these environment variables, and run Puma, which I used to run this app. And if you look at if you really look, containers are running right now, the Puma container is running, right? So I can actually bash, log into the container. Docker run -t -i and bash. Wait, sorry. Runtime. This is a container. It looks like exactly like a, if you think about it, it looks exactly like a Linux box. And you have your application. Actually let me run it like as it runs the application, because I don't literally have any paths or anything set. Maybe I can run it on the compile box here. Docker. Just at runtime. Right. You see gem list here. These are gems installed. I don't have, I can literally say Puma here. It should, the address. It'll run. There's no bundle exec, none of the nonsense, I can even run Rails here if I want, or Rails server, right? So it's like completely isolated. You don't deal with anything else outside. This is its own world, right? And it's amazing. You never really had the kind of flexibility that you get with it. And if you look at the list of packages, they're very, very minimal, right? I mean, you only have things that you need for the container. I mean, I install Vim because I want a Vim, but you don't generally have Vim in your production boxes. But you get an idea. So that's what's happening here. We have about 13 more minutes. I'm gonna save it for questions. I know a lot of folks have been awfully quiet.
Cool. Greg, you could probably stop your screen sharing as well. If you're done with that, we can always jump back into it. Yeah, and so I'd like to open it up if anybody had any general questions for Greg or anything specific. Cool. Well, I'm going to grab a few of the questions that some people filled out beforehand. Greg, you can stop your screen sharing if you'd like.
Oh, I did not. I have a lot to sink in. I'm sorry. I just packed it. I like to code better than.
Sure. Yeah, no, it's that was great. It's a good overview and just the general architecture and diving into it. And I think a lot of people are going to be diving into the Git repo to try it out for themselves and see what they can figure out. But just a few of the things that you need to keep in mind as you're just kind of sort of shifting your thinking about the way you deploy applications. So there's a couple of people working on some interesting things. People working on an e-commerce admin app, so they're trying to take their admin side of their application and turn it into, containerize it. Some people are looking to automate infrastructure, and and for questions, somebody wanted to understand how they're trying to take their entire production application portfolio and run it in containers. And I guess the initial side of that is, you need to kind of look at, and I guess this is what Steen was asking, but how do you go about evaluating the applications that you're currently running inside of your system, and what is the kind of compatibility, the issues that you might face when kind of transitioning to running an application in a container?
Nothing. And it's architecture. And it's basically how much can you take out of the application, outside the application in terms of configuration, right? Biggest challenges I have today with lots. By the way, I forgot to introduce myself. I'm a systems programmer. I write, systems programs for hyperscale, and most of my day I spend writing a distributed, highly fault-tolerant system for a managed platform as a service software. So it's basically, what I do is I take software and make it manageable, right? So work with several customers, and we biggest challenge for me is people don't know what packages they need, right? And people don't know, like literally, you can't blame them. Like, it's like you install a Ruby package, and you're like, you get a kitchen sink if you come from Heroku, or you are normally you're tied to so many packages that you don't know. That's the biggest challenge. If you can isolate the packages, you isolate everything, right? Second biggest challenge is taking configuration out of the application into more manageable, more loosely coupling the application away from your hard-coded stuff inside. And third, I think biggest risk is people don't like speed. I mean, you'll be surprised. Like, and people want to know, and the configuration sometimes is so tied to systems. See, there's a lot in Java applications. They somehow architect in such a way that you have to assign an ID to servers in order to perform some operation. There's really no loose coupling. So I think the biggest challenge is with the existing application is number one, you got to change it. Number two, you need resources to change it. So if you don't have that resources, you're not going to go anywhere. So, and it becomes counterproductive trying to containerize an application that cannot be containerized. Because nobody really knows what's going on in the application. From the application packaging standpoint, you actually have way better stance with containers because you can actually give whatever application packages they need. There's no restriction from an operational standpoint. You don't really care as long as it's not shell shock. Whatever. But
cool. So, I mean, one of the things about Docker is it's a kernel level abstraction on top of the infrastructure, and it's would you consider looking at Docker as one of the top options for an application that you have running on maybe it's a legacy application that's running on a server that's not doing so well, and you need to be able to figure out how to migrate it? Is Docker like the top choice for you to figure out how to get that application into a brand new box and run it?
Yeah, Docker is amazing. One thing I really like about Docker is it provides you, containers is one thing, it provides you the workflow. That's very important that goes to the containers, right? And I think it also, they've done a great job in extracting environment variables and making, exposing them. Docker primarily works, a lot of the linkage between containers works through environment variables. And Steen's point, he says, I depend very much on environment variable. That's amazing. I advocate for using environment variables. They're the most flexible and fundamental unit of systems programming in Unix, right? More people should use environment variable. I've been such an advocate. I wrote so much open source. I wrote the environment vagrant N plugin. I've written a lot of stuff to actually make applications use environment variables as configuration tools, and I still continue to use it. That's totally the way to go. And I, the second part of your question, I said I start up a DB container first, and then a Rails container, and then finally an Apache container. How do you go? How would this kind of setup work with your type of setup? You certainly, I mean, you certainly are going in the, yeah, it certainly works. You absolutely need to start up your database before you can get your application up, because your application wouldn't boot otherwise for the most part. And your web container, your Apache, it doesn't really really have dependencies unless you have like health checks that depend on your Rails app to be up. But for the most part, I mean that's a very typical hierarchy that you have going on, Steen. But do you also have a load balancer in front? How does that work? Because that's where the real value comes in, because you can actually start getting into atomic switches. So you can deploy applications in real time, do the switching without having to bring down an application before the other guy goes down. If you have like a HA proxy installed, you can like do it in real time. So you have like a lot of other advantages that the containers give you. And with like service discovery like Surf, Surf gives you, as soon as a member joins, that means a container will join the cluster, it'll throw an event. So you can actually switch your, your HA proxy or your, Apache for the matter of fact, to point to this new set of Rails servers you just boot up. So you can literally take down the old guys. I mean, without taking down the old guys, boot up new guys, do a switch when everybody's ready. So you can get like really creative infrastructure, architectures like that. Surf is great. You can also look at console. I try to bring in etcd, another configuration manager. It's a little, the etcd use case is a little high level than what most of the people would need, I would think. It's for most of us, I think console and Surf does a great job. I really like those two products. etcd, you have to bootstrap a lot of code, and it's not exactly easy to build up new clusters, and discovery is kind of convoluted, and people are working around it, I guess. But
so that's great, and I think that one of the questions I was there, it's interesting for me as well, is somebody's looking at API node deployment. So I think that you kind of stepped on that with high availability, and Steen is deploying container for each part of the stack. You're talking about a highly agile infrastructure that you're able to scale up and change. What are some of the cool things that you can see people doing with deploying like containers across multiple data centers, and using getting that last mile, or getting the speed of light variable out of the system? Like, what are some cool things that people are doing with the network infrastructure side?
Oh, it's completely elastic, right? So now you have this, I don't know if you heard of Kubernetes, Google's, what they've been doing with infrastructure, they kind of came out with this product called Kubernetes. It's very interesting. You literally set a state as what you like, and always make sure it runs as a state. So you want no matter what, right? It'll automatically scale. You don't do anything. I mean, as long as you have a good container going, you can literally just sleep and everything is taken care of, right? It's auto-scaled. It's not only based on, I mean, you have several variables that you can define for how you want to auto-scale. And it's in terms of erosion management, I mean, I think that's the biggest benefit. I mean, having my page really not go off in 3 o'clock. I mean, I have like actually reduced my alert levels on PagerDuty now, so I can literally trust my infrastructure is going to take care of. Don't wake me up unless an hour of shit happens, right? I mean, I'm still okay. As soon as, I mean, here's the house is falling down, I'm still okay for a while. Kubernetes is very, very interesting. Second thing is people doing, especially with Node, I've seen a lot of movement towards hardware. I mean, bare metal infrastructure, and that's amazing because moving away from cloud. I mean, cloud is great, but you still have the noisy neighbor. I mean, I work with security experts that the kind of things that they show me was just like, wow, right? No matter how much security you're going to put on your software layer, you're never going to get the kind of security on a cloud box. It's just like impossible. And I think with containers, you certainly can, because you don't have the noisy neighbor. You have the complete box to yourself, and you can come up with. I mean, all this the Rackspace guys came up with Open Metal, which is like OpenStack API, and we're talking to them, and you want to essentially build containers on bare metal and get the same level of flexibility that you get to the cloud API. A lot of work is happening in that bare metal space, and you put a node or something so evented on a bare metal box, it's fantastic. I mean, you get the performance. I think even Joint, the guys who made Node, completely go with. I mean, they are big on the bare metal Unix boxes, which is the Solaris boxes, I think. But you can literally run it on in K container, build it on whatever, and run it on Solaris, and you can run them on parallel, right? You don't have to like do anything just to see performance benefits. So you can do all this stuff with containers. I think you should give it a try before you use. You give it a try. It's a whole world out there.
Yeah, so Prashant actually has a good question. He's talking about measuring the performance of various containers. And I'd like to actually kind of bring that into the perspective of DevOps as well. You talked about using containers as part of your infrastructure, etc. What type of cool tools are coming out that allow you to monitor your infrastructure and performance of containers and kind of give you that cool visualization of how the network is operating, etc.?
Operational, so application level operational. You have well. The tools for every level, right? So if you look at network level stuff, you have Boundary. Boundary guys are pretty cool. New Relic guys a little expensive, but they give you so much data that you're okay to pay like $150. And I don't like their pricing model. I think it's complete horseshit. But I end up paying like a lot of money, so I wouldn't. And they have some product that they actually deliver. There is StatsD. There's a whole lot of them. I plainly like to take a top every second and put on a fluent beatbox, but that's it. That's me. But yeah, I mean, cool tool for visualization. I don't know. I mean, one thing I'm really excited is things are on my phone now. I mean, I literally can get so many applications and visualizations on my phone. I don't really go for the big screen visualization. If I do go for big screen visualization, it's mostly for fancy on my wall that, we have this uptime, we have 99.99 uptime, whatever, right? So I actually haven't been in the whole visualization charting space. And
but I'm assuming that there's an API, so you find one that's there and you can plug it in and start,
for the containers themselves, the actual API.
I mean, there's logging, right?
You didn't have anything before. I don't think anything special came out for containers that give you extra information that you didn't get before. If there is, I'm not aware of it, so I'm not really sure.
Cool, that's great. Well, Greg, thank you so much for giving us this awesome workshop. Part a little bit conversation, part demo, a little bit of overview of how to use Docker, and some kind of sort of opening up our minds on where we can use it inside of our daily infrastructure lives. I'd like to invite everybody just to check out Greg and what he's done in his GitHub repo, and certainly give him some comments or some issues or ask him some questions so you can help improve it. It's amazing that he's basically provided us some free code to get our Docker and our containers up and running. He's also available for air pairs. Meanwhile, Greg is also busy running his own company. You can find Greg at AirPair. It's actually airpair.me/notch. KN0TCH. And of course, just submit a request to airpair.com for Docker. We have multiple Docker experts. Greg is one of our top-level experts. We use him religiously for Airpair's infrastructure, and always asking, what does Greg think when we're thinking about making a network change or doing something interesting inside of our environment. So thank you, everybody, for being here, and I'd like you to enjoy the rest of your week, and have a good day.
Thanks.